Arithmetic sequences. An arithmetic sequence has a common difference, which we use the variable d for, between consecutive terms, starting with the first term, which has the variable a. So a sequence of numbers, so here we have a sequence of numbers, it's just separated by commas, so right now we're not adding them, we're not subtracting them, we're not doing anything to them, it's just a pattern of numbers. So what we want to do is want to look at these numbers here. We want to determine what is the common difference between these numbers. Now, first of all, the first term here, our a value, would be 6. That's the first number in the pattern. And then we want to see what number do we add to get to the next term and to the next term and so on and so on. Now, you can figure it out visually. You have to add 7 to go from 6 to 13. But you can figure it out by taking one term and then subtracting the previous term. So that should be 6. So d would be equal to 13 minus 6, which gives you 7. So you'd add 7 to go from 6 to 13, and you can see that the pattern continues as we go through. Now for this one, it's a little bit more difficult to see, going from 12 to negative 23 and then to negative 58 and so on. So using this trick will help us out. So our common difference d, so negative 23 is my second number. I would then have to subtract the previous number, which is 12. That gives me the common difference of negative 35. So what the pattern is, we are adding negative 35 each time to get to our next number. So that's why the number is getting smaller and smaller, because we're adding a negative number. Now, if I give you those sequences that we had on the previous slide, I could now ask you, what is the 20th term, or what is the 100th term? And you could just keep adding 7, adding 7, adding 7, and so on until you get to the term that you want. Or we can come up with a general formula here. Now, the notation that we use for these terms, so a lowercase t with a subscript number, so term 1 is what this stands for, is just whatever the a value is. So term 2, so lowercase t with a subscript 2, will be equal to, we start with the a value, and then we add the common difference, which is d. The next term, term 3, so we'd have to start with the previous term, so a plus d, and then adding the common difference again, d. Now, simplifying this, d plus d would give me a plus 2d for term number 3. Now, for term number 4, again, starting with the previous term, which we just saw was a plus 2d, so the common difference was added twice. But now we'd have to add the common difference again. 2d plus d would now be a plus 3d for term number 4. Now, we can continue on in this way, but what I want to see is, what is the relationship between the term number and then the coefficient on d? Now, that would be a coefficient of 1 in this case. So for term number 3, the coefficient on d is 2. For term number 4, the coefficient on d is 3. So what you'll notice here is that for whatever term we want, we are adding d one less time than the term number. So a general formula that we can use to calculate any term number that we want, so term n in general, for whatever we want to calculate, we do have to start with the the first term of a, but then we're adding n minus 1 times d. So n minus 1 is 1 less than the term number of the common difference. Alright, so a very easy example here. Given this sequence of numbers, what would be the 15th term? So in this case here, I'm figuring out the 15th term. So using that formula, n would be equal to 15. And looking at my sequence of numbers, I have to determine what the a value is and what the d value is. So the a value is the first term, which is 2. The d value is the common difference, so what we're adding to get to the next number. Now, you can just see this one visually pretty easily. We're adding 4. So if I want to figure out term number 15, so lowercase t with a subscript 15 would be equal to 2 plus, so that's the a value plus, and then n minus 1, so 15 minus 1 times d. I don't need to put d though because I know that it is 4. So again, just like in the last slide, what this means right here is for term number 15, that means that we're adding the common difference one less time. So we're adding the common difference 4 times. So I can just calculate this on my calculator. Term number 15 would be 58. So instead of just adding 4, adding 4, adding 4 over and over, one small calculation can do the work for me. Now, given the information that we have in a question, I can ask you to solve for any part of that formula. So this question is a little bit different. We have the first few terms of the sequence, but then we have dot, 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 so we don't know what's in the middle there. But here we see that the sequence is ending at 81. That is the final term. So what we want to know is how many terms are in the sequence. If this is term number 1, this is term number 2, term number 3, dot, 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 this is term n, but we don't know what n is. So that's what we have to figure out for this question here. So this will involve a little bit of solving. So what we do know from this information, our first term is negative 3. Our common difference, now we can see from the pattern, what are we adding? We're adding 3 each time. Now what I also know is that term n, that final term is 81. Now the equation or the formula starts with term whatever, term n is equal to. So in this case, 81 is what we would have calculated, just like the previous question. That will be equal to negative 3 plus n minus 1 times 3. So we don't know what that n is. We don't know how many times the common difference has been added. This is what we're going to solve for. So in this case, when I have my equation here, I can just expand this part out here. So that will turn into plus 3n minus 3. Now, moving both of those over to the other side and kind of skipping ahead here, so that would be minus 6 on the other side. I would have to add that, add 6 to the other side. So if 3n is equal to 87, then I would divide both sides by 3. And that will give me an answer that n is equal to 29. So the 29th term of this sequence would be 81. So it's important right now that you can look at a sequence like this and figure out what the first term is, what the common difference is. But at any point, I can ask you to solve for any part of that equation. So make sure that you can fill in the additional information as well.